So you're in the lab and you heat sodium chlorate, and the oxygen gas that you collected was occupied 57.2 milliliters at 22 degrees Celsius, and you have a pressure of 734 torr. So you're like, okay, I can use PV equals nRT to find the moles of O2 that was collected. Now note, your vapor pressure of water at 22 degrees Celsius is 19.8 torr. And what this is saying is that you have basically gaseous water in whatever volume you collected. And that also contributes to the total amount of pressure that you collected right here. So we'll keep that in mind. PV equals nRT. Well, let's plug in all our values. For P, I'm going to set that aside for now. For volume, well, we have 57.2 milliliters. So if we just divide by 1,000, that gives us liters, and that's what we want to record it as. So 0.0572 liters is equal to moles, which are what we're trying to find, times R, and we're going to try to turn this into atmospheric pressures. So we're going to use 0.08206 for R. And our temperature, well, this is 22 degrees Celsius. We want it in Kelvin, so plus 273 will give us 295 Kelvin. Now our pressure. Here's the thing with our pressure. Our total amount of pressure is 734. This is our total in T. But H2O also occupies 19.8 torr, right? So this is also in torr. Now, what is O2 then? So we said the total amount of pressure is 734. Our water vapor essentially is 19.8. So O2 is whatever is left. So if we say 734 minus 19.8, well, that gives us 714.2 torrs. So that's actually the pressure that O2 occupies. Now we want to convert that into atmospheric pressure. So we say 714 torr, and this is 0.2 as well. Then we say times 1 atmospheric pressure per 760 torr, and this is given to you at the bottom of the exam. So this gives us an answer of 0.940 atmospheric pressures. So that's what we're going to plug in right here, 0.940. So let's solve for n. So n, if we solve for it, gives us 0.00222. We'll stick to 3 significant figures because that's what we have all throughout, 3 significant figures. We can also write this as 2.22 times 10 to the negative 3 moles. So that's how many moles of oxygen gas that we have.